So this is 11.2.3. You need to have watched the video on 11.2 iteration first. I'm just going to talk through this exam question, which is from the Welsh Board C3 paper, Jan 2010. So we're starting off with this function. What I'm going to do is let f of x equal 2 minus 10x plus sine x. And we have been asked to show that we have a root alpha between 0 and pi over 8. Notice we are in radians, and you will always be in radians for this topic. It isn't to do with the sine x, it's to do with the 10x. So if we were dealing with 90 degrees, so 10 times 90 is completely different to 10 times pi over 2. Sine of pi over 2 and sine of 90 in the relevant units would equal the same thing. So it's to do with this part of the functions, and radians just gives us a better scale. So you have to be in radians. Now it's easier to spot here because I've got pi over 8, but in an exam question where the interval was say 0 to 0.3, you wouldn't necessarily spot it, apart from just thinking that that range is a little bit small maybe. So to do this question, we're going to do f of 0 is equal to 2. F of pi over 8 is equal to, I'm assuming that you can plug that into your calculators, so we've got that, and we are going to go with our conclusion. So as f of x is continuous and there is a change of sign in the interval, this time I'm going to write it in because I've got 0 to pi over 8. Or you could say there is a change of sign between 0 and pi over 8. I want to say okay, so make sure your conclusion shows that needs a conclusion. Make sure your conclusion is answering the question, and as we've said before, generally if you go back to the question and rewrite out what it says, so it has a root between those two values, you tend to be on the right lines. So we've been given a recurrence relation, so we can see that this has come from adding 10x to that side and dividing by 10. So just like we were doing in the previous examples, we're making x the subject. So that's what's happened here. Sometimes in an exam question, this part of the question might be show that this is a recurrence relation for that. So you'd need to show the steps that you would take to get x, make it the subject. So we're starting with 0.2. So I want x0 is equal to 0.2, and I've been asked to find the values of x1, 2, 3 and 4, writing down the value of x4 correct to 5 decimal places. It's a good idea to write your values down to more than 5 decimal places for the previous ones if it only wants x4 correct to 5 decimal places, because if you make a rounding error, you will lose marks, and you don't want to lose marks on this. It is literally substitution. That's it. So I think it's a good idea to go to more than 5 decimal places when you're writing down your values, unless you're very confident with your rounding. So 0.2 equals, so that starts us off. Then we're going to input the iterative formula. I'm in radians. Okay, so 0.2 I'm in radians. So pressing equals is going to give me x1. So we've got x1 is equal to what we're going for. X2 x3 That should be a 2. And x4. To 5 decimal places, so that was the one they wanted to 5 decimal places. If you give the previous ones to less than 5 decimal places, you won't get the marks. So you have to go 5 or more decimal places than what it's asking for. So that's that part. So that's got me up to there. Okay. So then we want to prove that this value is correct to 5 decimal places. So I'm going to set up an interval. So what we've done here is we started off with the interval between 0 and pi over 8, and we've cut it down so that we've got 1, 2, 3, 4, 5 decimal places. So this needs to have 6. So it's 0.2220, and I'm going down to 1.5 as the lower bound, and then my upper bound would be 2.5. Now, careful here, you need to substitute it in to f. You don't want to put it into your iterative formula, and that's quite a common mistake because you've just been working with this. I'm not interested in that. I'm interested in that up there because that is equal to 0, and therefore I can look for a change of sign. If you put it into here, all you'll end up with is something very similar to what you've already got, because we know that the root lies between those two, so you can't do your proof. So we are putting it into that function. So 2 minus 10x plus sine of x. So that one should give you 4.6 times 10 to the minus 5. And is equal to minus 4.5 times 10 to the minus 5. Conclusion. Notice I'm using the same conclusion for the first bit of this every time. So it will always be the start bit will always be the same. So as f of x is continuous, there's a change of sign in the interval. But then this conclusion needs to answer the question. So we're trying to prove that we're correct 5 decimal places. Therefore, 0.22202 is correct to 5 decimal places. Or therefore the root, I suppose. So it's referring back to the fact that we're checking the 5 decimal places. This one up here was saying there's a root between those two values. This one down here is checking the number of decimal places. In both cases, I'm mentioning continuous and mentioning change of sign. It's just getting your head around those two, and it's just answering the question. So that's that last part. 7 marks in that case.